Okay, so you guys, you still need your computers. Did they die? Because you didn't plug them back in?
Yeah.
Okay.
All
right, so we solved for x-intercepts, and we were talking about how that relates to Desmos, which is not up anymore. There's Desmos. Nope. There's Desmos. Nope. There's Desmos. Nope. Where's mine? Over here. There we go. Found it. All right. So then the equation that when we solved for the x values, we solved x squared minus 9x plus 8. So when you look at my red equation, which was the original one that was given to us, and then you look at my green equation, those are like almost the exact same equations. What happened between the red one and the green one? It translated, no, the red one to the green one, translated up 8. And that's because I added 8 to it. Because it did used to say, equals negative 8. When we added 8, we pushed it up 8. And now we are just looking at the x-intercepts, which were 1 and 8, rather than before we were looking at the intersection between the red one and the blue one. So what we're going to be doing today is you can either, when you check your answers, either type them in as 2 separate things, or if you type them in as 1, we can look at the x-intercepts, because it will say equals 0. But we're doing today's by factoring. So we're algebraically solving these by factoring. So we look at the first one. And you get super overwhelmed when you look at the first one, because of all that sines and cosines everywhere. If that overwhelms you, let's just change out cosine. Let's call it just like A. Okay? We'll call it A. So I'll say that cosine x is the same thing as A. You don't have to write that down. I'm just saying that. But like, every place I see a cosine, I'm going to make it A. And there's also a sine x in there, so what should we call sine x? Sure, why not? So if we think of this being like 3, now this is cosine squared x, I'm going to write it as a squared minus, and there's my b, and then there's another a squared equals 0. How would we factor that equation?
Take out cosine.
Oh, well, not that one, but this one with the easier looking stuff in it. I would factor out the greatest common factor, which is an a squared, right? We factor out that a squared, and we write it out here, and we have 3 minus b equals 0 left over. And then once it's factored, you solve for each factor. But that is not the equation. So let's actually do that. We're not going to factor out a squared. What are we factoring out? Cosine squared. So we'll have cosine squared x, parentheses, then we have left over 3 minus sine x. So once it is factored, now we set each factor to equal to 0. And we're going to solve for each factor. So when I go to solve cosine squared x equals 0, so I square root both sides, plus minus, but when I square root 0, minus to 0, I don't need plus minus for 0. For this one, I'm going to move the sign over, so I'm going to get 3 equals sine x. Once you have it factored, it's the same thing that we did for our assignment last night. It's just, let's take cosine x and figure out where that is 0. Let's take 3 equals sine x. Oh, sorry, sine x and figure out where that is equal to 3. And then put all our answers like x equals fancy bracket plus the answers. So where is cosine equal to 0? Pi over 2? Is that the only place? And 3 pi over 2. We're going to do 3 pi over 2 because the directions say between 0 to 2 pi. And then how about the other question? Where is sine equal to 3? In the unit circle. 1. It isn't. You're correct. It is not, but why? What's the highest value that the y can be in the unit circle? The y value, I'm sorry, the sign, as in y sign. 1 is the highest value it can be. It's never 3. So this is like extra information that we can't put an answer with. So then our answers would be pi over 2 and 3 pi over 2. Now, we're going to check this on Desmos. It's a little tricky to type it in. So we're going to do it together. All right? Now, since we're back doing trigonometry. We're back doing trigonometry. Go ahead and go over to this wrench. And let's make the step for x's pi over 2. So that takes my my x axis, and now we're in pi form. And to type this in, since it says equals 0, we're just going to look at the x-intercepts. I'm not going to put a second one that's just y equals 0. To type it in, you got to type in 3. And then the cosine, you can either type it in, or if you go to the functions, cosine is under there if you want to type it that way. But as soon as you type it in, you'll see a parenthesis show up. You have to put the x in parenthesis. And this is the weird part, is you have to put the squared on the outside. Otherwise, it's not going to work. That's not how we write it on our paper. But that's what you're going to have to put it. How did you type it in?
I just typed in cosine, like COS, and then I clicked the A squared button, and then X.
Oh, you used like the A squared button? Let me see. Did you? And you had the 3 in there?
The parentheses, and then A squared. X.
Okay, when we did it this way in my other class, did you type in the rest of the function yet?
Not yet.
So when we typed it in, it wasn't working, but maybe because I didn't use that A squared button, I just used my keyboard, so maybe it'll work, but.
Because when you do the keyboard, it does like a subscript.
Let me try. So what's my next part? I'm sorry, I can't see it. Sin x. Okay, minus sin x.
Yeah, it doesn't work that way.
It doesn't work your way? And then cosine, oops, I'm going to just try this. Cosine. Oh, it did work when we used, that's weird, because if I did the caret, it wouldn't work. But when I use this A squared, that's weird because it's the same thing. Anyway, that's good to know, because I was like, I don't like when it's typed in a different way than the way we write it on our paper. Now, we're just trying to find between 0 to 2 pi. There's like infinitely many solutions. We're only looking from 0 to 2 pi. So if we click on pi over 2 and 3 at pi over 2, you can see that those are right. What if the answers you got on your paper didn't match what was on Desmos? So you just change your paper, right? No. If I get different answers on Desmos than are on my paper, if you just change your paper, you're not learning what you did wrong. You have to go figure out your mistake, or you're never going to know what it was, and you're going to keep doing that mistake. That's why we have a check. Okay, let's do the next one. So you look at this equation, and it might be confusing because of the signs in there. Let's substitute, instead of sign, let's make it u. So we'll have u squared plus 3u plus 2 equals 0. So if I substitute u, can you see how we're going to factor this one? It's going to be like guess and check factoring, where I have 2 parentheses. U and u, they're both plus, and then 2 and 1. We check it. Yep, that equals 3u in the middle. But it's not u. What is it? Somebody say sig. Sine x, and then plus 1 and plus 2. So once you have factored, we set each factor equal to 0. We're going to solve each factor. So we have to figure out where does sine x equal negative 1? 3 pi over 2. And then where does sine x equal negative 2? It never does. That's undefined. You can't use that answer. So we should only have one answer. Let's check. I have these typed in, but go ahead and type them in. I want you to check. I want you to be able to get this faster and faster. So just watching me do it isn't going to help you 100%. You go to Desmos and type it in. See how fun that graph looks, if it's fun. And then you just want to look from 0 to 2 pi. From 0 to 2 pi, there should just be one solution. It should be at 3 pi over 2. Okay, let me go to the next one. All right, next one. What are we trying to do? What are we trying to do? Set it equal to 0, make it equal 0? Yeah. So that we could factor. If it doesn't equal 0, you're not going to be able to factor. Or you won't be factoring correctly. So set it equal to 0. And then what is our very first step of factoring always? Greatest common factor. Is there one?
Yes.
Cosine squared x. So we're going to set each factor equal to 0. Question? Rachel? Question? And then I'm going to solve each factor. So for the cosine, I need to, or for the first one, I need to square root both sides, square root plus minus, but it's 0. So cosine x equals 0. And cosine is 0 on the y-axis. And then the second one, I'm going to have to square root as well. I get plus minus. And when you square root 1/2, that's like square rooting 1 and square rooting the 2 separately. So we have cosine x equals plus minus radical 2 over 2 after you rationalize that one. And that's plus minus. So how many answers are we going to get for this one? Oh, there should be 6 total, but I just meant for this part, sorry. Yeah, 4 for this one. Remember that was a mistake a lot of this meeting. So we didn't use our notes. Make sure you're using your notes when you do your assignment. So we have x equals, we're going to put them in order. These are all the pi over 4s. So we have pi over 4, then pi over 2, 3 pi over 4, 5 pi over 4, 3 pi over 2, 7 pi over 4. Then once you have those, let's go type it in. Desmos to check. So you can either type it in as 2 separate y equal equations and see where they intersect, or you could type it in where it says equals 0 and look for the x-intercepts, which is where it would equal 0. It's your choice.
Oh,
Yeah, so how do you do the fourth now?
You have to
can
do
hit
it
squared.
And then go back.
And then hit backwards and make
No,
it
there's
four?
no.
Oh, there's a actual.
No, that doesn't work.
Yeah,
it only supports
yeah.
squares. It only supports squares, so you have to use parentheses otherwise.
Crazy.
No, I did it, and then it was like, no, you can't.
Well, so this, okay, so remember when I was trying it originally, I was telling you, this is how you have to write it before I realized you could use a squared. So you have to put the fourth on the outside. Another way you could write it, I did this is how I did it last year. I'll show you how I did it last year. Because I don't necessarily like that, that 4 on the outside, because that's not how we write it on our paper. Is you could write 2 cosine and then hit that squared x and then times cosine squared x, maybe. I think that's how I did it last year. I'm trying to remember. Minus cosine squared x. Nope, that didn't work. It didn't like that. What does it not like? Use parentheses, so it didn't like the times symbol. Nope, still doesn't like it. Maybe I'll try them here too. There. So it liked it when I typed it in this way, where I typed in 2 cosine squared x multiplied by cosine squared x, which is cosine to the 4th x. So it was okay when I put it in parentheses. But yeah, I mean, that would be the only tricky thing about using Desmos is making sure you're, typing it in a way it likes. But I don't know if you noticed, it told me that there was an error, and when I clicked on it, it told me what to do. It worked for you? Well, let me try that. So 2. What are you trying to hurt me? Oh. If I type in 2 cosine, so you did x and then you did, where is that? Where? Oh, this one here. And then you put a 4. Woo! Look at that craziness before I... Oh, I put it in the wrong place. Does it work doing it here? So it doesn't work doing it here. Okay. So yeah, that's kind of like how mine was. If you look at the black one right here, Rachel, I was able to do it that way.
Yeah, that's how I do it.
Yeah, and that works. It's just, the 4 really doesn't go there. So that's the only thing I don't like about it is the 4 doesn't really go there when you write it on the paper. So writing it this way also works where you have cosine multiplied by cosine, but you have to have in parentheses.
Yeah.
Okay. So anyway, when you do that, it does have 6 answers, and guess what? They're in order. You could check your order as well. You don't seem that excited by it. Okay. All right. I'm going to skip the next one because there's one that we've already done just like it. I want to get to the back. Okay, so by factoring, you have to have it set equal to 0, which this one is, check. So after it's set equal to 0, we have to determine if there is a greatest common factor. But in order to do that, you have to be able to see each term separately. How many terms are there? Yeah, terms are separated by plus or minus signs. So if you look very carefully, there are 4 separate terms here. There are 4 separate terms. So when we look at those 4 separate terms, is there a greatest common factor? No. No. Not in all 4 terms. But there are some greatest common factors if we group it. There are some greatest common factors. When you group it, you have to have the plus sign in between. There are some common factors if we group it. So I can take out the GCF from the first group of sec and x. And out of the second group, what GCF would I have? Just the number 2. So I have plus 2, and then 4 cosine squared x minus 3. So now from here, what we have is now we have two really big terms. And when you look at those two really big terms, is there a greatest common factor between those two really big terms? Is there something in common between those two really big terms? So I'm going to factor out by GCF 4 cosine squared x minus 3 from both terms and put it in front. After I factor that out, I'm left with secant x plus 2. And once I factor that out, what is in between my two parentheses is multiplication, so it's factored. And once it's factored, what do we do to each factor? Now we're going to solve each factor. So after I solve each factor, I get cosine x equals, do you have a plus minus? Plus minus radical 3 over 2. So I need to know where cosine is radical 3 over 2 and plus minus makes all 4 quadrants. Where? That's going to be all the pi over 6 values. The second place, or the second part is where is secant equal to negative 2? Maybe I don't have my secants memorized.
But cosine 2.
So cosine x would be negative 1/2, which is going to be in quadrant 2 and 3. And at what? They're going to be at the pi over 3s, but in the second quadrant, it's like 2 pi over 3, and then we've got 4 pi over 3. So we're going to put these in order. Pi over 6, 2 pi over 3, 5 pi over 6, 7 pi over 6, 4 pi over 3, and 11 pi over 6. And how are we going to know for sure that we did it right? There you go, put it in Desmond.
And we put the factor.
Say that again?
We put the factor.
I wouldn't. I put the original because what if you factored it wrong?
Yeah.
But you put a wrong factor in, and you're not going to know that you have the wrong answers.
Yeah.
I would try to put the original in.
On this page, I put the equal sign between the two the first time. I was like, that's not right.
Right. You would have to do what we did before lunch, where you do y equals this, y equals that. If you're going to do them as two separate, or if you just do it after you move over that, you don't do them. But sometimes we factor wrong. Yeah. So this is a fun one when you type it in. Why do you think this one has some asymptotes? Because of the secant, right? So if you're not sure if you did it right, you've got Desmos to check. And Desmos works just great on your phone if there's an app. And if you are not sure if your order of your answers is correct, this will help you with that too. But if you don't practice typing it in, like you saw, it's kind of weird about typing it in. If you don't practice typing it in when you're here, you're going to get on your own and like, not go right into it. We have one last example once you've typed this in and made sure that it worked. Try the last one on your own. I'd like to see if you can try it on your own. And I will be passing out your worksheet, which is the assignment, but remember we have a quiz next class. So this worksheet's short, but we go to quiz next class, and it's not over this worksheet. Only over the identity, just over the identity. One of them is right on the side of my computer. You have an extra X. I just see it. Was that it? Did you find the one?